Hi, thank you so much for joining our live stream. I think we can start because a lot of people have already joined. So if anyone was attending our last stream, welcome back. If you're here for the first time, thank you so much for joining. My name is Anya, and I'm a business development manager of Kmine. If you haven't already, please follow our LinkedIn page where we'll post our announcement for future streams. So today we will keep talking about resource modeling and strategic planning in Kmine, and more specifically auto design and production scheduling. If we go over our agenda, we will see the overall what we are reviewing today is the new design functionality of Kmine, and that includes the design of the final pit, pushbacks, dumps, and we also will see the scheduling process and analyze the results. So let's just review what Kmine offers in general. We are a mining software company that has been on market for almost 30 years, and we provide one standalone application that is customizable and adaptable for each company's needs. That allows us to work basically with a company of any size and provide a reasonable pricing because our solution is model-based. So the application itself is based on its own patent graphic core, which processes the information faster, and the application aims to cover most of operational needs, such as, for example, 3D modeling, resource estimation, planning, equipment management, and so on. So what does it mean specifically is that we have 12 models for open pit and for underground mining. And each of these models can be configured, adjusted, enhanced for each deposit. Basically, our engineers not only set up the whole company's infrastructure during the implementation of our solution, but also assist our clients at any stage of work, creating 3D models, planning schedules, and estimating resources and reserves. Each of these 12 models can be used as a standalone model and also can be used in conjunction with each other. So each company can pick its own set of models covering its own specific workflow. So what means it's like different departments of a company can exchange information within one space without obligation to create SharePoints, fight compatibility issues, or like waste time importing and exporting process or adjust the data. We also offer custom solutions, so you can see on the right part of the screen solutions that we currently offer. It's end-to-end planning that allows to automate planning for all of the stages of the production process until the moment the product is actually loaded. IoT platform works on the web-based interface. That solution transmits real-time information from IoT devices and personnel, displaying information like gas consumption, tracking location of equipment, and personnel, creating a dashboard based on this information. And later on, you can analyze it and receive heat maps where you can see where your employees can have the most frequent problems, when the equipment needs maintenance, etc. And also other custom solutions that we build are integration with OpenPit and underground dispatch. These integrations basically allow to obtain and visualize information from dispatch systems. For example, we have experience working with Wenco, MineStar, ACK, Modular, and others. Overall, we just do offer customized integration all the time, whether it's in our system or really any external information system that would allow us to receive information and import it into our application. So basically, you can manage all of the mining process inside of one interface. So today, our software also allows to evaluate projects, create digital twins, create life of mine plans, calculate the resources, and so on. And that's why we provide different types of services. If we can just switch to the next slide. So all of our models were created basically based on the real use cases and real project, not only just theoretical knowledge. And that's why we also provide these consulting services. since we have a lot of mining engineers, geologists, planners, surveyors, and other professionals inside of our personnel. So since this stream is the continuation of the last one, let's just remember where we left off last time and the results of the previous stream. So last time we built a block model of a graphite deposit. Then we created a deposit optimization project and determined the most attractive option for us. And after that, we broke this final contour into pushbacks. So again, just to remind everyone what pushback is, pushbacks are successive controlled phases of mining operations. So they are part of a mine development stage. In the perfect world, of course, pushback consists of these unique, spatially contiguous volumes that can be mined using existing mining equipment and also that comply with practical geometric constraints in the mining process. And the point of using pushback is to determine the time and place of excavation of a specific volume of rock mass. So you can supply the factory systematically, you can moderately remove the rock mass from the pit, and it really depends on the equipment. And if we want to optimize economic indicators in the production process using pushbacks, we need to start the development of the next pushbacks as late as possible and work it out as quickly as possible. So to make sure we plan pushbacks in a practical manner, we need to take into account like transport communications. That means that before we start the scheduling stage, it is necessary to build pushback design. And then we define groups of and according to the updated services. So now you see on the design parameters that are required actually to build the final position of the mining operations. These parameters are ledges, angle of inclination of the side, and the parameters of the roads. The reference point for us is the wireframe of the pushback that was obtained at the stage of the strategic planning. So let's build isolines along the horizons for detailing the constructions, and let's take the lower horizon as a basis and move from bottom to top and vice versa depending on the situation. To build dumps, we need the parameters of the dump tiers and the parameters of the roads on the dump and the preliminary territory on which dumps will be placed. So in this case, the strategic decision means all of the decisions that significantly affect the economy after they are made. For example, what type of transport will be used. So depending on dimension, the width of the road will be designed. And will there be like communication corridor on the surface of the pit? This will determine the distance between the pit and the dumps, and also the distance is significantly affected by the potential of the deposit. In the event of change in the economy for the better, the boundaries also can be expanded. Now, where will be the optimal place for dumps, reloading warehouses? Will they be temporary or permanent? We can also answer these questions during the development of the schedule stage, as in the process, the stages of mine development can be tracked and optimal placements will be determined. So many other questions will be closed. So to determine the lifetime of mine, there are several well-known formulas. The study of these formulas are based on real mines derived empirically. So check it out, the results of this research. The table provides the basic information about the study and the results that are visualized on the graph. You can see that conceptually the results are similar, but as a rule, the most accurate option is the one that is based on more examples. So let's take for our example the formula that includes the experience of about 342 pits. First, you need to determine the daily productivity, and then using the resources of the deposit, determine its lifetime. Using the values that were obtained as a result of determining the optimal contour, this is 179 million tons, and the year-round production cycle of 365 days, we get the life of the open pit, which is about 17.5 years. So building pushback is an important step in creating a mine plan in the process of detailed design of the final stage of the development of each pushbacks should be created. The main one is the definition of a communication between several pushbacks, for example, building roads. The performance of one pushback should smoothly transition in the development of the second pushback. So a communication message between the main points of loading and uploading at all stages of work can be maintained. In order to speed up the process of the building, such project, we just started development of automatic design in KMI, and at the moment we continue to fill it up with more functionality. I just wanted to ask to stop the video for a second so I can explain more. So in the manual mode, building pushbacks can take a lot of time. Basically, if you experience it, maybe up to 1 day per pushback. But what if one road didn't coincide with another? What if from the other side you have to basically manually rebuild everything? And this increases the construction time. And in order to spend a minimum amount of time on the creation of such projects, we create the possibility of interactive construction, where the user will be able to quickly perform the complex constructions and to be sure that they are correct. So now we will just demonstrate how the automatic design model works in KMI using the example of creating several pushbacks that were obtained from the Pit Optimizer model. The model allows you to build both top-down and bottom-up. So the first pushback, as well as for building of the final contour from scratch, is proposed to use the bottom-up construction method. And in order to define guidelines, it's necessary to create as lines, which is possible using the standard KMI functionality. So you can restart the video now. So the resulting other lines must be prepared for subsequent constructions to remove narrow areas where mining is not possible and to smooth out the contours. For this, again, we just use the standard functionality of KMI. This is basically the beauty of using software. Everything is one environment and can be used at any time during the build. So to start building, you must specify the basic closed contours from which the constructions will be performed. So specify the lower contour as a mark of minus 30 meters. And after pressing the calculate button in the automatic mode, the edges will be rebuilt in accordance with the parameters specified in the main table, which must be filled in advance. So let's add a road to build it automatically from bottom to top. As you can see, it was created from the lower horizon to the upper one in a matter of seconds of constructions. It's not uncommon to have to adjust the road to different conditions. For example, to change the location of the road, you can change the point of its beginning, complete its constructions at the end of any exit, change the width of the exit part of on one or on two sides. Also, you can add horizontal inserts both automatically and in a specific place, just simply by filling the table. And the direction of the road also can be changed both in a whole and in a part by adding Uturn in a specific place. Adding turns is done automatically, like everything in this model. If you need to expand the turn, you can use additional features in the table, namely radius column. So to complete the construction, just click Apply button, and the edges will be added automatically in the place of virtual lines. Then you can continue building in manual mode if you need to correct something, build a frame or other constructions. So in the process of automatic design, both one and several baselines can take part. Also, different slope regions can be used to define unique parameters for pit areas. With the help of the layer editor and the property editor, it's possible to place the necessary elements in the right place. It's highly recommended to keep the file structure in order so you can quickly access all of its elements. So we can start building the second pushback. We will use a different method, top-down, since we have clear boundaries for the expansion of the pit along the top, and it will be easier just to make a construction that will correspond to the previous pushback. To start building, let's use the create object with magnetic snapping command. This command, like all others, can be called using just shortcuts configured at kmine. For example, this command by default is invoked by the key combination Alt-G, and we repeat the existing contour and the place of the expansion of the pit with one line along the upper edge. And we will make sure that all the places can be worked out and there are no narrow sections and other things and we'll prepare the contour for further construction in the manual mode using the inscribe object command just to smooth it out. So let's build the edges and proceed to the construction of the exit part. In order to make a viable pushback project, it's necessary to repeat the configuration of the previous pushback in a place where mining will not be performed. Let's add the road with the same parameters and in the same place as the previous pushback. So in the process of constructions, we must know exactly and understand which section will remain in the pit and which will work out at this stage. We will complete the construction of the exit in the place of interest for us, and the rest of the road will be rebuilt. And in order to connect two boards with roads, ramps can be built to meet one another. So let's add a second exit and complete its extension at the required location. So next we will have a choice what to do. You can add another road at the conjunction of the exits. You can add a U-turn on one of the roads, or you can confirm the construction and continue taking the updated outline as a basis which is likely to give the desired result. So let's do it. So let's reassign the reference edge in accordance with the horizon elevation and smooth out the sharp sections using the command that we already know. And next we will continue building communications. In our case, it's roads for heavy dump trucks. We're going to use the available settings, and it's possible to get the desired results in the shortest possible time. We will add turns, horizontal inserts, and complete the construction in a narrow place. And then we will remove unnecessary and refine some constructions if we need to. So let's build a wireframe and place objects in the appropriate layers. And after that, we can start building the next pushback. Number 3, we will use a method similar to the previous one, building from the top edge, from top to bottom. By the way, if the user basically made an error and specified an edge that does not correspond to the horizon in the table, construction will start from the horizon marked in the table, but with the configuration corresponding to the selected line. And after we perform the same operations, we can proceed to do on. So in this pushback, the northern part will be widened and the road can be completely moved to another place and it will be rebuilt. So we can leave the part of the road from the previous pushback and that doesn't fall into mining for maximum correctness of the construction. Overall, in the process of building subsequent pushback ideas, we can get the ideas that where the roads can be joined in order to leave them as much as possible for later use. If we want to do that, it's necessary to rebuild the previous pushback and leave the pillar in the right place, which is basically a section that will not be developed. Also, the indication of a selection of exits will help the user to make the most comfortable decision for further actions. For example, the location of the turn. If we leave a horizontal insert for the purpose of further docking with the last pushback, during the construction process, various substrates can be used. For example, the draft of the previous pushback in the form of lines or a wireframe, a block model, other lines, and much more. So it's basically enough for user imagination, just depending what he needs. So gradually we get from to the bottom of the pit. We will add horizontal inserts, turns where necessary, and we will complete the construction, create the lines of the project and the wireframe, place them in appropriate layers. And finally, we can start building the last pushback. That pushback will also reflect the position of the pit in a worked out form. We'll use the same method, expanding the pit and building using the top edge. So let's create it and smooth it for the most correct construction of the mining area. By the way, if the user is experienced enough and accurately sees the final results, he doesn't might not have to repeat the section of the road that will be left in the pit. And for example, add an additional limiter in the process of determining planning section. So let's repeat the section of the road that will remain after working out the last pushback and will be part of the final contour. So let's stop mining at the planned junction of two road section and just add the second road. We complete its construction at the same place and get a neutral insert between the two exits, which we left in the process of building in the previous pushback. Further construction will be carried out in two directions. One is the existing and previously achieved, and second is the deepening of the new section. In order not to repeat all previously completed sections by automatic design, you can just simply copy them into the project and adapt several constructions one for another. So let's prepare the next edge in order to use it as a reference and copy a part of the pit that will not be modified for further use. Let's adjust the junction of the three roads manually so that the dimensions of the turns in all directions are observed. In the process of automatic design and design in general, we should remember the basic concepts of productive design. So roads should be as straight as possible with a minimum number of bends and turns. It's better to arrange horizontal inserts only at the junction of several roads or at sharp turns. And also, it is necessary to minimize them, and this configuration will allow achieving optimal performance in the removal of rock mass by dump trucks. Also, the design must be mineable in all cases and in all its areas. Roads also should smoothly transition from one pushback to another, providing a connection to the communication corridor. There are many more aspects to consider, but for our simple example, it will be sufficient. So let's prepare the next page in order to use it as a reference and copy a part of the pit that will not be modified for its further use. Let's return to the construction and define the prepared upper edge as a reference to the corresponding horizon and perform the construction of with virtual lines. Then we add the road at the junction to the previous section as to get a continuation. And let's stop the construction in a narrow place, accept the construction and remove the extra edges. So let's let result obtain for the fact that all areas should be mineable. Let's remove the bottleneck from the construction. Maximum efficiency is achieved with customizable shortcut combinations. By the way, shortcuts can be also recorded as macros on a computer. If supported by a device, then you will be even more efficient. So you can see that during 20 minutes, we received 4 completely finished pushback projects, and one of each is the final contour of the pit. And this result will be used for subsequent mine planning activities. So the results of the design pit should be compared with the result of the original shells, and we will see it just in a moment. So the best indicator for assessing the implementation of the design of the pushback is the deviation in volume and mass of rocks. We compare geometric, volumetric, weight, and quality parameters. And the allowable deviation is considered to be for ore is minus 5%, since the lower part of the pit is most often not possible to work out because of its width, and plus 10% for overburden, since the addition of roads, ramps to the project as a rule entails additional justified volumes of rock mass excavation. So the results will be as close as possible to the desired if the size of blocks is not large and the constructions are tracked in the process of all horizons with the baseline moving in according to the lines. So now let's look at the process of creating dumps in the final position using the same automatic design model. There are no significant differences between the constructions, and it's necessary to take into account the fundamental aspects. First of all, the design of dumps will be created from the bottom up, since the dump is basically formed in this way, tier by tier. And as a rule, we have a territory where it's possible to place a dump. So initially we start the dump design mode and the construction direction from the bottom to top, and then we set the bounding edge, the base one from which the construction will begin. Now let's add one road with the parameters that are slightly different from the pit design. On the dump, access to each tier must be provided. So for this, we set the width of the berm drive to be equal to the width of the road, and we add horizontal inserts on each tier of the dump. In the required place, we will complete the construction and add another road in the place where the first one also began. So we will direct it in another direction. We also apply the construction and slightly correct the result obtained so that access is provided to all sections of the dump. The actions are performed in the automatic design model and it's many times faster than manual construction. So I hope that you're convinced already of this. And in the end, we just build a wireframe and place the result in the appropriate place. So at the moment, the scheduling model in K-Mine is capable of working in several directions. The first direction is characterized by a manual search for a suitable sequence of excavation of blocks and of rock mass, indicating certain dependencies and mining sequences. This method satisfies the need to predict the position of mining operations for specified time periods. It can also be successfully used when the direction of the development of the deposit is well known and does not change with the time. The second method is automatic. Its main feature is that it's also able to find solutions, meet targets, specifying certain planning parameters using unique algorithms. Also, a combination of the two schedule methods also can be used. Initially, we find the necessary sets of blocks using the solution search method. Then we use the result as a limiter to determine the planning area and manually determine the sequence of mining areas, gaining volumes for excavators. So to create a mining plan, we need two parcel boundaries that were defined by the pit optimizer model and work out in the automatic design mode. This is the basis for creating a subsequent plan, since the pushbacks will be used as delimiters of planning areas of the block model. Also, some additional data will be needed. Our plan will contain planning intervals, years, and will cover the entire life of mine. And therefore, we can say that this plan will be something between long and medium term. So the process of preparing data for planning can be different as the data is different and the requirements for the project. This example will show how to record the belonging of a block to a specific pushback and in a separate field of the block model. First, you need to create an additional field in the block model. To do this in Kmine, it's necessary to recreate the block model indicating the additional field, setting the appropriate data type, and also for the convenience of using block model in the schedule model, we can combine block models blocks in height. In the original block model, they are 7.5 meters, and we indicate 15 meters. Quality also will be recalculated at an weighted average. The updated block model has been created and placed in the base layer, from where it can be moved to the desired location. So next, using the set properties command, we will limit the visibility of the block model using the wireframe obtained as a result of constructing pushback in the automatic design task. First will be pushback number 1, and we will display all of the blocks that are above this wireframe. For the convenience of displaying block model blocks, you can set the scaling factor for the blocks, which will allow you to set the visual distances between them. So next, to assign a block to a specific value, you must use the set value command in the set properties task. In this case, the software will write to the visible blocks on the screen belongings to pushback number 1. Then in order to display the blocks that belongs to pushback number 2, it's necessary to specify geometric dependencies as follows. Show blocks above the wireframe of pushback number 2 and then below pushback number 1. To do this, we need to do two geometric dependencies. And next, we use the same set value command in the set property task to specify number 2. And let's check the relevance of the performed actions and display wireframe of the pushback number 2. Let's do the same thing with pushback number 3. We display blocks that are above pushback number 3 and below pushback number 2. And we will write the result in the pushbacks field under number 3. And we're going to do the same for the last pushback and add another geometric constraint to take into account only those blocks that will be in the area of the last pushback. We will use a linear object as an additional limiter. We indicate all the blocks that fall in the middle of this polygon and will be attributed to the pushback number 4. So let's recheck the work done and visualize only those blocks that relate to a specific pushbacks in the pushback field from 1 to 4, one after another. We see that the expected result is obtained and we can move on. So to start creating a plan, we need to restrict the block model so that only those blocks remain that will take part in the project schedule. Next, we call the schedule command and fill in the required fields, the name of the project, the location of the project file on the local computer, select the block model, determine the type of block model, and we have this block model with the material class attribute of the rocks and indicate the field in which the data is located about the weights of rocks. For a mineral, we indicate the quality indicator. In tables, you can limit the display of data by hiding columns that are not of interest. Also, other useful commands are available in the table editor. Next, we define the planning areas. We have three options. Create area, which is the drawing mode. It allows you to manually define the boundaries of the planning areas. Load areas from the block model, that allows you to load areas from the block model from its separate field, and we will use it since the corresponding attribute has been prepared. And create area from visible blocks, which allows you to group visible blocks, block model blocks from into a separate area. Just to do this, use the set properties command. In the edit sections in the table, the rock mass is presented broken down by horizons. Also, you can get a content for with the location of blocks by horizons by opening the list next to the name of each section and hide or show blocks related to a particular horizon. Then you need to set the parameters of the sections in the case of an active root element in the project tree, and the settings will be applied to all sections. And we will set those parameters that will be same for all the sections. After that, we set the remaining parameters for all sections, and in order to more accurately understand the picture with the development of the mining operations, it's proposed to use pushback wireframes as a substrate. These parameters determine the method of mining the site and can be changed at any stage of the project development after the recalculation of the plan that they will basically come into the force. Now let's add time intervals. Let's create annual plan for 17 years for life of mine as we defined during today's presentation. And we will add excavators and set up manual method for mining the deposit. We add 3 excavators, set the procedure for mining sections sequentially from 1 to 4. Then the development on the subsequent given equipment begins only after the completion of the development of the previous one. So productivity of the rock mass, regardless of its type, would take 12,000 tons per day. Several more activity events for excavators can be also possible. You can set a specific day for activity if you want to achieve something specific. Copy the excavator and for the other two. For one of the excavators, instead of the activity of completion of the market of the mining, we will set it to partial when we reach a certain level of mining and the excavator moves to the next section. And remember just to save your progress from time to time so your data and notes will be safe and sound. So we will calculate and get instant results. The interval will show which blocks are processed in each time interval. The results are visual information about the blocks, tabular data, and daily visualization of mining. Also, it's possible to upload the resulting data in the form of polylines and wireframes, but more on that later. As I mentioned earlier, this type of planning can be used as a forecasting tool or the final stage of the planning after determined mining areas in a specific period that is obtained as a result of the search for solutions. The table editor allows you to call the chart editor, which you can quickly visualize tabular data in the form of a table. The graph itself is customizable and its functionality resembles Excel software. In terms of plotting, you can assign data to any axis and choose the type of the data display, axis labels, etc. Now, it can be seen that the removal of the rock mass does not fluctuate and it changes only due to the amount of the available time in the time interval. In the space of the block and possible for recess. So let's build a graph based on the tabular data to see the results of the first iterations. The graph shows a certain undulations in terms of the removal of rock mass from the pit. These fluctuations are due to the amount of overburden mined during the opening of a new pushback, for example, mining overburden or pre-stripping. Ideally, these volumes should be aligned with the fleet of the existing equipment, ensuring the maximum involvement of the equipment and its operational efficiency. By the way, you can also use the quality as an addition to the quantitative indicator of the rock mass and define them as target parameters for the plan set. Next, let's try to set for the first interval the ceiling of the excavation of the rock mass at the level of 12 million tons. So let's build a graph and get acquainted with the result. As you can see, the amount of rock mass is observed, but the amount of ore has been decreased, which is very logical since there is no need to open the ore body. So let's set the rock mass removal rate as a goal for the whole plan and get acquainted with the results. As you can see, the goal is achieved simply, but the fluctuation in the balance between ore and overburden are significant. Therefore, it's worth paying considerable attention to the process. Alternatively, in intervals in which the amount of ore predominates over the amount of overburden, it's necessary to gradually begin the stripping of the subsequent pushbacks and thereby equalizing the rock balance. And we will leave this question basically to your fantasy. But let's look at the results of uploading planning results as wireframes and polylines. In this case, the block model affects the accuracy of building wireframes. The smaller the block size, the more accurately the wireframe and polylines will be built. The results obtained this way can be used in subsequent planning stages. For example, the development of annual plan for the development of mining operations, 2, 5, or more years, depending on the what you need. So let's just summarize the results of today's stream. First of all, we presented a fundamentally new model for Keymind software. It's AutoP design. Its main features were presented to your attention, and we hoped we intrigued you and proved with a good example how much faster all the constructions can be made using this model. Also, we touched upon the topic of preparing initial data for scheduling. Such operations can be performed for other purposes, the creation of the block model fields or the assignment of the data to them as a universal function. And in the end, we considered the possibilities of the scheduling model carried out several iterations and got familiar with the results. All of these operations can be interconnected and performed in the course of creating a mining plan. For all these tasks, the block model, of course, is the basis. And the final result is considered of the considered tasks depending on the reliability of the data in it. For example, if there is no accurate data in the input of determining the optimal contour, then of course it's clear that all further steps will be meaningless. So what's an entrance basically is what is at the exit. Also, I would like to note that the block model of any stage of exploration, whether it's operational or horizontal, always correlated with the resource block model. And data are compared and further search for inconsistencies and the causes should be done. So this way we can state that the geological information is one of the main ones and requires a high degree of attention. So that's basically it for today. We'll see if we have questions here. I would like to give the floor also to our mining engineer, Vitaly, who will answer your questions. Hi, Vitaly, do you hear me?
Yeah, I can hear you well. Hello, Anya.
And, okay, perfect. So first question is like, what are the most important and main requirements for the pushback?
Okay, so particular consideration lead two categories of constraints for the pushback design. So let's split them for two of them. So first of all, it's geometrical dependencies, and the second one is limitation on the quality and quantity parameters. So when we talk about geometry, it means like spatial. So it's requirements about the road design, about the geotechnical gradients, about pit wall. So another. And other very important geometrical constraints are width, the width of the pushback. So, because all we know that then bigger will be pushback, that longer, that more time we will need to obtain the ore, because it will be a lot of stripping. And in case if we will have the narrow pushback width, so it means that our productivity will not be reached. So the next one is smoothness. It's about when we would like to connect the previous pushback to the next one. And of course, we will not create like corners between them, like in 90 degrees, because it will be unmindable at all and it will be unstable. So the connection between pushbacks should be smooth. And the last geometrical dependencies is continuity. So the uh, finish of the uh, previous pushback should be like a start for the next one. So they should be connected to each others. And when we talk about limitation on the quality and quantity, it means that we have um, to provide the necessary amount of the ore in the necessary condition. Uh, Yeah. Okay.
And what are the stages of the open pit development?
Okay. So um, based on my experience, I can say that we have four main stages of the pit development. So the first one, it's like a preparation of the field when we creating the roads, creating the different kind of communications between the future pit and our factory, for example, or something like this. And the next one, when we um, of course, and when we trying to open our ore body, so it's like preparation study and pre-stripping study. And the next one, it's when we trying to reach the production capacity. So when we trying to open how much ore is possible to provide the necessary amount of the ore for the next periods. And the third study I would like to mark, it's when we working at the production capacity. It means it's our uh, the uh, the how to say, it's a best time for each company, for each mining company, because during this time we are making much more money mm, from the all the periods. So and the next and the last one, it's uh, bit attenuation. So when all our pushbacks are almost finished, we trying to finalize them and maybe decide to mine somewhere else a little bit, just to how to say, just to finalize the pit activities. Yeah.
And how to minimize the hauling distance between during the scheduling?
Mhm. Okay, so the, when we creating the design for the each of the pushback, usually we create one or two roads just for not very big mine. Um, and usually when we trying to make very accurate plan, we will increase amount of the our existing roads, of the planning roads, and in this case we will reduce our haulage distance. So we will create the temporary roads that will be like temporary conclusions, temporary decisions for us. And using these roads, we will make our haulage much shorter. And as we know, this is a very huge part of the all of our expenditures. It's hauling. Yeah, and of course, we always can just mine out all of these roads and back to the our project design.
All right, I think thank you so much, Vitaly. I think that's it. That's all the questions for today. Thank you so much, guys, for joining. Don't forget to follow our LinkedIn page, and hope to see you guys at our next event. Thank
Okay,
you.
thank you.
Bye.
Thank you. Bye.